So we're still with right triangles, okay? Trigonometry only deals with right triangles, and basically what happens is anytime you have a right triangle, there is a certain ratio between angle measurements and the sides across from them. There is a ratio that can be determined by angle measurements and the ratio of the sides across from them. And basically, what mathematicians decided to do is just create this whole section called trigonometry based on those ratios. And the three main trigonometric functions are sine, cosine, and tangent. Please don't say them wrong. Don't say sin, it's sine, right? Cosine, tangent. Okay, and what does the sine, the cosine, the tangent do? They never can stand alone because the sine, the cosine, and tangent, they're talking about the ratio of sides based on a certain angle. So it's never just sine. It's sine of an angle because that angle's telling you where you're going to be looking at. So we're going to say the three trigonometric ratios are sine, cosine, tangent. And there's a special word that tells us what the sine pairs, what the cosine pairs, what the tangent pairs. And that special word is SOH CAH TOA. Can everybody say it? SOH CAH TOA. You are going to be saying that over and over and over in your head. So what does the SOH CAH TOA stand for? Well, the S in SOH represents the sine. And remember, I told you sine never stands alone. Sine is always of an angle. Sine, cosine, tangent, it's always of an angle. And you'll understand once we do more of this. So the sine is going to equal the opposite side over the hypotenuse. That's the SOH part. The S for sine, O for opposite, H for hypotenuse. So sine of an angle will pair the opposite side over the hypotenuse side. And remember, trigonometry can only be used on what kinds of triangles? Right triangles, exactly. All right, so that's the SOH part of this. Then you have the CAH, right? The C in CAH represents cosine. The shortcut for cosine is COS, cos. And remember, sine, cosine, tangent, they never stand alone. They're always based on what? An angle. So it's cosine of an angle will equal A over H. The A is the adjacent side, and H again is the hypotenuse. So we went through SOH, we went through CAH, now we're going to talk about TOA. The T in TOA represents tangent. The T represents tangent. The shortcut for tangent is tan, T-A-N. And remember, just like sine, just like cosine, tangent can't stand alone. It's always tangent of an angle. And that's going to equal the opposite side over the adjacent side. That's O over A. All right, are we ready? So now we want to find the sine of angle A, the cosine of angle A, the tangent of angle A. So everything is in reference to which angle? Angle A. This is our reference angle. So based on angle A, I have to decide which side is opposite angle A, which side's the hypotenuse of that triangle, and which side's adjacent to angle A. Right? The hypotenuse, we always know how to identify. How do we always know how to identify that hypotenuse? It is across from the right angle. So do we all agree lowercase c is the hypotenuse here? Now the side across from angle A, the side opposite angle A is the side across right there. So which one is opposite angle A? Lowercase a, that's the opposite side. And the adjacent side always forms the angle with the hypotenuse. The adjacent side always forms the angle with the hypotenuse. So do you see how angle A is formed by AB, which is the hypotenuse, and AC? So the adjacent side is always the other side that forms the angle. It's always the other side that forms the angle. That's the adjacent side. A sine, cosine, tangent could only be used on the acute angles. It's never used on the right angle. We never use the trigonometry on that right angle. Only the acute angles in the triangle. All right, so we want sine of angle A. Well, sine is so. And what does sine pair up? Opposite over hypotenuse. So opposite angle A was lowercase a over the hypotenuse, which is lowercase c. Right, now I want to find cosine angle A. Well, cosine angle A, we have SOH CAH TOA. So do we all agree cosine is CAH? C-A-H. And what is cosine pair? A over H. So that's the adjacent over hypotenuse. Well, which side's adjacent to angle A? Isn't it lowercase b? Over the hypotenuse, which is lowercase c. B over c. Right? And then it wants tangent of angle A. So again, SOH CAH TOA. Which one is tangent? SOH, CAH, or TOA? TOA. TOA is tangent. So what is tangent pair? Tangent pair is the opposite over the adjacent, O over A. So which side's opposite angle A? Lowercase a. Which side's adjacent to angle A? Lowercase b. Okay, we're going to do this with real numbers, so it might make more sense once we put real numbers into this. Is everybody done copying this? Can I move on? Okay. So now we want to find the three trig ratios. Sometimes they call them trig ratios. Sometimes they call them trig functions. When they say the three trig ratios or the three trig functions, they mean sine, cosine, tangent. And they're saying find these three trig ratios for which angle? Angle A. So everything's in reference to angle A. Well, I'm going to look at this triangle. One side is missing. This is a 3, 4, what? 5 triangle. So I'll just label that side. So I want sine. Remember, shortcut for sine is S-I-N. So, but don't call it sin. It's sine. And remember, sine, cosine, tangent never stands alone. So they want sine of which angle? Sine angle A. We want cosine angle A, and we want tangent angle A. Right, what is that special word that helps us know which trig function pairs the sides? What's that special word? SOH CAH TOA. Good, SOH CAH TOA. So now everything is based on which angle? Angle A. So let's label everything based on angle A. So which side is opposite angle A? The 3, the 4, or the 5? 3 is opposite angle A, so I'm going to write opposite there. Which side is the hypotenuse? 3, 4, or 5? 5. And which side is adjacent? 4. All right, well, sine angle A, that's SOH. So which one does SOH pair? O and H. What does O represent? Opposite, which is what number? 3. Over H, which is what number? 5. So the sine of angle A is the ratio of 3 over 5. What about cosine angle A? Which one is that? SOH, CAH, or TOA? CAH. All right, well, CAH pairs which two? A and H. Which side's adjacent to angle A? 4 over H, which is the hypotenuse, that is 5. So now we want to find tangent of angle A. Is tangent the SO, the CA, or the TOA? TOA. So now tangent pairs O and A. So which side's O? Opposite? 3. Which side's adjacent? 4. Now we're going to do the same 3 trig ratios, but what am I switching? The angle. Does that mean the fractions will change? Yes. So now everything's not in reference to angle A anymore. Now everything's in reference to angle B. So once again, we have a 3, 4, 5. Not Nora or Kaylee. They're holding up the class right now. Somebody else tell me which side is opposite angle B. Which side is opposite angle B? AJ. 4. All right, which side is the hypotenuse? Which side is the hypotenuse? Mia. 5. And which side is adjacent? Which side's adjacent? 3. So now it says find the 3 trig ratios. What does that mean? I want sine, but sine never stands alone. Which angle is it of this time? Sine, angle B. You got it. Then I want cosine. You could never write sine, cosine, or tangent by itself. It always has to have an angle with it. So it's cosine, angle B. And lastly, we will have tangent, angle B. Those are the 3 trig ratios or trig functions. All right, what's that special word that helps us know what to pair? Jeff.
SOH CAH TOA.
SOH CAH TOA. All right, sine. Is sine SOH, CAH, or TOA? So, do we agree that's O over H? So, what are we doing? O is 4 over H is 5. All right, what about cosine angle B? Somebody tell me, is that SOH, CAH, or TOA? CAH. What am I pairing this time? A and H. Good. Adjacent and hypotenuse. What numbers are those? 3 and 5. And last but not least, tangent angle B. Is that SOH, CAH, or TOA? TOA. I'm pairing O and A, which is going to be 4 over 3. Can we keep going? All right, we want to find the 3 trig ratios for angle A. Well, once again, what happened? I am missing a side. Can I find that missing side? Absolutely. So, before I do the Pythagorean theorem, guess what I'm going to tell you to do? Divide by 2. When I divide by 2, I get a 4 and a 5. What is this? 3, 4, 5. So what's that missing side? 6. So I want, everything's in reference to angle A. I want sine angle A. I want cosine angle A. And I want tangent of angle A. Which side is, wait, what's the special word again? SOH CAH TOA. All right, you tell me, Will, which side is opposite angle A? 8. Navia, which side is hypotenuse? 10. Amanda, which side's adjacent? 6. Michael, tell me, what's sine angle A?
Sine angle A is 8 over 10.
Good. Do we all agree this ratio is a fraction? What must we do to all fractions? Simplify. So 8 over 10 is not the acceptable answer. What do we have to do? divide by 2, so we get 4 over 5. All right. Matt, tell me, what's cosine angle A?
6 over 9.
Which simplifies down to?
305.
Will, what's tangent angle A?
4 over
Yep, could you do the bigger numbers first? 8 over,
6.
good, which is 4 over 3. All right, we can skip number 4 because it's just doing the same thing just now on which angle? B. So you guys go ahead and do number 5 on your own, and then we'll do number 6 together.
Oh, I think, yeah, I thought you were saying it's something different. Oh.
The male way.
The what?
The male way.
All right, are we ready? So we're missing a side here. Before I do Pythagorean theorem on 24 and 26, my instinct is let's make these numbers a little smaller. Let's divide by 2. When I divide by 2, I get a 13 and a what? 12. This is a triple. What is it? 5. So, since the fractions need to be simplified, can I just do it on this triangle, do you think? This simplified triangle, right? Because wouldn't we just have to make the ratio and then just divide by 2 anyway? So I'm just going to do everything on this simplified triangle. Does everybody understand what I'm saying? So I'll say this is A, this is C, this is B, our reduced triangle. So now we want to find the 3 trig functions for angle A. Well, 12 is opposite, 13 is the hypotenuse, and 5 is adjacent. So I want sine angle A, I want cosine angle A, and I want tangent of angle A. What's that special word? Not Nora or Kaylee, not Jeff, somebody different. What's that special word? So, that's ka. Toa, that was painful, right? All right, SOH CAH TOA, SOH CAH TOA. All right, so I want sine angle A. Sine angle A is going to be so we want opposite, which is 12, over the hypotenuse, which is 13. Cosine angle A is ka. So I need the adjacent, which is 5, over the hypotenuse, which is 13. And tangent is TOA, so I need opposite, which is 12, over adjacent, which is 5. How many people got this correct? Excellent. All right, we're stepping it up a little bit. So find the three trig ratios for angle A. Well, they're not giving us any sides. All they're giving us is that angle B is a right angle and angle A has two sides congruent. Well, remember, if a triangle has two sides congruent, what else does it have? The base angle. So what does it mean for these two base angles? They both have to be 45. Goodwill. They both have to be 45. Do we know about a 45, 45, 90 triangle? We sure do. Opposite the 45s are x and x. Opposite the 90 is x root 2. So we want to find the three trig ratios for angle A. So what's everything in reference to? Angle A. Do we agree that BC is opposite angle A? And AC is the hypotenuse? And that leaves AB being adjacent. So now I'm going to write out SOH CAH TOA. I need sine angle A, I need cosine angle A, and I need tangent of angle A. All right, well, sine is opposite, which is x, over the hypotenuse, which is x root 2. Bear with me, guys, because there's going to be a whole section like this on your test. I cannot leave it like this. I must simplify. The first thing I'm going to do is simplify the x's. Don't they cancel out? So then I'm left with 1 over root 2. I still cannot leave it like this. Why not? Yeah, there's a radical in the denominator, so I need to rationalize. How do I rationalize? Top and bottom. You got it. So sine of angle A would be root 2 over 2. All right, now we want cosine of angle A. Demetri, tell me, what is the cosine of angle A based on our graph using the variables? Good, but just tell me. You got it. This time it's adjacent over hypotenuse. So it's the x over x root 2. Didn't we just do it above? So do I have to go through this whole process all over again? No. What do we know that simplifies down to? Root 2 over 2. Exactly. Annalena, tell me, what is the tangent of angle A using the variables? Good. Guys, what's x over x? 1. It's 1. X over x, x divided by x is 1. 5 divided by 5 is 1, right? 6 divided by 6 is 1. Any number divided by itself is 1. Who has a calculator? All right, in your calculator, do tan button 45. Yes. Oh, yours might not be in degrees. Tan 45, enter. Yeah, you're not in degrees. Okay, does anybody, I'm going to teach you tomorrow how to put it in degrees. Does anybody have this little calculator? Anybody have it? You're in radians, but I'll teach you how to get out of radians tomorrow. All right, just do tan 45, enter. One, look at that, guys. Isn't angle A 45 degrees? What did we do? Tangent of angle A, which is 45 degrees. We got it equals 1. The calculator told us 1. We must be correct. Isn't that crazy? All right, so now we're going to do the same thing. Says find the sine, cosine, and tangent of 30 degrees. So what are we doing? We have a right triangle. We have a 30-degree angle. If I have a 90 and a 30, what does that last angle have to be? 60. You got it. Now, I don't have any side lengths here, but do we know the sides of a 30, 60, 90 triangle? Yeah. Opposite the 30 is? No. X. Good, Will. Opposite the 30 is X. Opposite the 60 is? X root 3. Opposite the 90 is? 2X. I feel like we're in a photo shoot. Okay. So we want sine 30, cosine 30, tangent of 30. You're welcome. That was awkward, right? A little bit. Yeah. Okay. So everything's in reference to which angle? Everything's in reference to which angle? 30. Everything's in reference to which angle? So which side's opposite 30? X. Which side's the hypotenuse? 2X. And X root 3 is the adjacent. Remember I told you there's going to be a whole section like this on your test when we get to it. There won't be any quiz, just straight test. No quiz here, just test. So, what is that special word? SOH CAH TOA. So now I want sine of 30 degrees. Well, that's opposite, which is X, over the hypotenuse, which is 2X. What happens with those X's? They cancel. What am I left with? 1 over 2, which is a half. Will, on this calculator, do sine 30 enter? We got a half, right? 0.5. Isn't 1 over 2 the same as 0.5? We got it. Okay. So now let's do cosine 30. Well, cosine is CAH. Do we all agree that's X root 3 over 2X? Once again, what happens with the X's? They cancel. So now I have root 3 over 2. Is it okay to have a radical in the numerator? Yes. So that's perfectly fine. Last thing I need is the tangent of 30, which is TOA. So we want opposite, which is X, over adjacent, which is X root 3. The X's cancel. So now I'm left with 1 over root 3. Can I leave it like this? No, I need to rationalize. Multiply by root 3. We get root 3 over 3. Oh boy. Okay, let's keep going. All right, more problems. So it's telling us if the tangent of angle M is 7 over 24. So now I'm sort of working a little bit backwards here. I'm going to write out my special word. SOH CAH TOA. Writing out my special word. Everything's in reference to angle M, right? So now they're saying tan angle M equals 7 over 24. All right, bear with me here. Do we agree that tangent is TOA? What does TOA pair? TOA pairs the opposite side over the adjacent side. So if I go to my triangle to fill it in, everything's based on angle M because it says tangent angle M. That means opposite angle M has to be what number? 7. Which side's opposite? Right here. So this is 7. And then adjacent to angle M is what number? 24. So isn't this bottom side the side that's adjacent to it? So this is 24. This is a triple. 7, 24, 25. Dimitri? So tomorrow, yes. Right now, this is just practicing all the like pairings of the different ratios. Tomorrow, you're going to see how it helps us. And then the day after that, there'll be word problems where it really shows you how it helps us. Okay. So now, I said, now that I filled out this triangle, now they're saying, well, now that you have the triangle, find the cosine of angle M. Well, cosine is CAH. So I want adjacent to angle M. Which number is adjacent to angle M? 24 over the hypotenuse, which is 25. So we are 24 over 25. All right, number 9. Find each missing angle. So they're saying the tangent of which angle is 9 over 40. Well, let's look at this triangle. This is a 9, 40. What's the last side? 41. All right, so they're saying tangent of which angle is 9 over 41. So I'm going back to SOH CAH TOA. SOH CAH TOA. We know tangent is TOA, so we're opposite over adjacent. Omar? What is it? Yes, can you tell us the answer first? So which angle is 9 opposite and 40 is adjacent to? Yeah. It is angle A. Okay, you may now go to the bathroom. All right, why is it angle A? Because they're saying 9 has to be opposite this angle and A has to be adjacent to this angle. So don't we agree that 9 is opposite angle A? Is 40 adjacent to it? Yeah, opposite and adjacent. So that is all talking about angle A. So now it's saying cosine of which angle is 40 over 41. Well, cosine is CAH, so that means 40 has to be adjacent and 41 has to be the hypotenuse. So again, we're looking at our triangle and we're going to say, okay, well, 40 is now adjacent to which angle? Which angle is 40 adjacent to? Isn't it still angle A? Is it ever the right angle? Never the right angle. It can't ever be the 90-degree angle. So it is adjacent to angle A. Is 41 still that hypotenuse? Yeah, so once again, we're talking about angle A. You all do letter C on your own. All right, sine is opposite over hypotenuse. So 40 is opposite which angle? B. Is 41 the hypotenuse? Yes. All right, number 10, we are going to label the sides of the triangle if sine angle A is 1 over 2. So we're going back to SOH CAH TOA. And sine is so that means 1 is opposite and root 2 is the hypotenuse. So what are we going to do? We're going to label this triangle, all based on angle A. Opposite angle A is 1. The hypotenuse is root 2. Now you can do the Pythagorean theorem. You can to find the missing side. Or, does anybody know what kind of triangle this has to be if I have a 1 and then a root 2, which also is like an x and an x root 2? Dimitri? This is a 45, 45, 90 because 2 of the sides follow its pattern. So what does that mean for the other side? It must also be a 1. All right, I'm going to skip letter B. Let's go on to this one. I don't know what it's asking. Okay, thank you. Find sine angle C. Okay, perfect. All right now, sine, cosine, tangent, trigonometry only works on what kind of triangle? A right triangle. Do we have a right triangle here? No. This is not a no solution problem. We're just going to have to manipulate things. Does anybody know what I'm going to do to get a right angle? Excellent. We are going to draw an altitude. And when I draw that altitude down, what happens to that 10? It becomes 5 and 5. Now, look at this right triangle. This is a triple, 5 something 13. 12. So everything's in reference to angle C. 12 is opposite. 5 is adjacent. 13 is the hypotenuse. So we want SOH CAH TOA. So you guys tell me, what sine of angle C? Good, 12 over 13. All right, back to quadrilaterals. Did you miss them? No? Okay, so it's saying we have a rhombus. What do we need to remember? We need to remember that all the sides of a rhombus are congruent. We need to remember that the diagonals bisect each other in a rhombus, and that the diagonals are perpendicular. And the diagonals bisect the angles, but that's not so important here. So when they tell us that RO is 18, what does that mean for RB and BO? If RO is 18, RB and BO are each 9. HM is 24. So what does that mean for HB and BM? 12. This is a triple times 3. Does anybody know what the missing side is? Jeff? 15. This is a 3, 4, 5 times 3. Okay, so now they want us to find the cosine of angle BRM. I first need to find angle BRM. So follow your letters. B to R to M. That's this angle right in here. I'm going to call it angle 1. So I'm going to use this triangle. Here's my right angle. Here's angle 1. I have a 9, 12, 15. And I want the cosine of angle BRM. Write out that special word, SOH CAH TOA. Am I going too fast, or are you all keeping up? Yeah. All right, Ethan, tell me, cosine, is it SOH, CAH, or TOA? Cosine, SOH, CAH, or TOA? CAH. Good. All right. CAH pairs what and what together? Ethan.
What?
Cosine pairs what and what together?
Adjacent and hypotenuse.
Good. Which side's adjacent and which side's hypotenuse?
Adjacent is 9 and hypotenuse.
Good. Guys, can I leave it like this? No. Simplify it down to 3 over 5. You guys all do the tangent of BHO by yourself. BHO, which is right here. That's angle 2. All right, you all tell me tangent of angle BHO. That's TOA. We want opposite and adjacent. What is it? 9 over 12, which simplifies down to 3 over 4. How many people got that? Excellent. All right, last problem for today. Given isosceles trapezoid, QRST. Well, we know if it's isosceles, the legs are congruent. So then it says side 17, the upper base is 10, the other leg is 17, and the bottom base is 40. Now they're asking us find the sine of one of the acute angles. When it says find the sine of one of the acute angles, your only options are those bottom base angles, either Q or R. Why? T and S are not acute. What are they? Obtuse. What do I need to do? I need to draw in altitudes. You got it. So when I draw in those altitudes, we get two right triangles. What happens in the middle? Rectangle. If the top is 10, the bottom is 10, which leaves how many units left over? 30. So that's 15 and 15. This is a triple. Something 15, 17. AJ. 8, 15, 17. Does it matter which angle we choose? No, I'm going to choose angle R. And what do we want? We want sine angle R. Go back to SOH. What is the sine of angle R? Who's got this? Jeff? What's sine angle R?
Oh, it's 8 over 17.
You got it. All right, kids, we are done for today. There's homework. It's a work.